Today we're going to be looking at stacked bar charts. These are the bars, and in between you have the stacks. And as you can see, this is the continental population data that we were looking at with heat maps. These are now expressed as a bar chart. But before we go creating bar charts, we're just going to talk for a minute about wide and narrow data. So this data format is called narrow. And what narrow data is that there's one numerical column, which in this case is population, and every other column supplies an attribute regarding that data. So this is Africa is one category and 2010 is another category. So category, many categories, and then one single numerical column. And the advantage of this is that it's ideally suited for the computer to eat up. The disadvantage of it is that it's quite difficult to read because you can't compare across the continents and the years. Wide data, by contrast, is where you have this category across the top, continents, and this category down the bottom, years. And in between you have the numerical data. So it's quite easy to read. 2010 in Europe, the population was 734 million, right? And this is very easy for humans to digest, but it is serious heartburn for the machine to digest in the majority of cases. One case where this isn't the case, where this is the ideal data format, is when you're creating stacked data in D3. Now, it is possible to create stacked data using narrow data, this sort of data, and I'll leave a link in the notes from someone who's done it. I don't fully understand how he did it though. Therefore, I'm going to stick with the method that I fully understand, which is to use wide data to create a stacked bar chart. And that's what we're going to look at now. So we're back in our heat map graph here that we created last week, and we're going to change our data source from the from the narrow data we had earlier to the wide data we're just looking at. Don't need that, and can eliminate that. Now we're going to pay attention to what comes up when we log data to the screen. So Shift Control Backtick produces the terminal, Python-m HTTP server, let it go, launch the Fox. Command Option I opens the inspector, and here's our data, right, which it tells us is an array. But it's a kind of an array in that it's a D3 CSV array, right? So the fact that we're calling D3 CSV here means that the array arrives with an extra property, which is columns. Columns is not a property of JavaScript arrays in general, but it's provided here as a convenience property for operations like the one we're just about to create. So back here in the code, we're going to shut down the terminal, and we are going to manipulate some data, because this, I think, other than the pie chart, this is the first time we have to create a new data object instead of just using the data as it comes in. So the first thing we're going to do is we're going to create two helper arrays. One we're going to call primary category, and we're going to get that by mapping all the data that are keyed as years in data. So data map d.dyear. Secondary category, we're going to take the columns property of the array that we were just looking at. We're going to slice it so that we avoid the zeroth. We're going to slice from the first element on. So this will be the names of all the continents. We're leaving out year, which is the first element of that array, and then we're going to slice from that. Next thing we're going to do, we're going to create a stack function by with d3 stack and giving it secondary category as the argument for keys. We're then going to create an object called stack data, and stack data we get by running the function stack that we just created with data as its argument. Now we're going to log that to the console, and we're going to go over to the Fox now, and we're going to examine this very, very carefully. Right click inspect and click the console, and this is our array, our stack data array. So it tells us it's an array of 6 elements. Each element has 8 elements. So look at the first array, and we see the 8 elements are 2-element arrays, all beginning with 0. 0 to 479, 0 to 632, 0 to 830, and that there's a key, and the key is Africa. Okay, go to the second element. These is another set of number pairs, and the key is Asia. So what these numbers are the positionings of the stacks and the bars and where they'll be. These are the stacks for Asia. The first one is the stack for Africa. The last one will be South America. Yeah, because that's the last in alphabetical order. So that's how these things are. That's what the stack data is. It's an array of kind of arrays. So it's an object with the 2-element arrays, where to start drawing the stack, where to end drawing the stack, and everyone is associated with the key, which is the key or the secondary data that we created earlier. I'm calling them secondary data because they're the data that will be on the y-axis. The primary data is the data that's on the x-axis. This isn't a rule. I've thought of it all on my own, but so far it's working for me. I'll just run that again. So if we take stack data for each D, console log D, and console log D key. See what happens. Just grey this out. Save it. Reload the Fox. Yeah. So here's our 8-element array for Africa. 0479 0630 0803. And then the start element here is the end element here, and that's how they match up. And each of these 2-number arrays has a data object associated with it, relevant to that particular year. So this is 1980. The second one here, the year is 1990. The third one, the year is 2000. So that's how the data is arranged, and it's necessary to know that in order to see how we're pulling it out to create the bars, the stacks, and most fascinatingly of all, the tooltips. Okay, back to the code. So the first thing we're going to do, we're going to clean up the remnants. That is the consoles, the print console, logged console stuff that we had. We're going to move our data creation before scales, because it doesn't make any, like, you can't have scales before you have data. So that was a mistake on my part, misplacement. Kill the old convenience areas that we had. We're going to resize the dimensions. So we're going to go 900 high by 633. Sorry, 900 wide by 633. Hide. what else do we have? And we have to change the scales. So our scale band, our X scale band, instead of using continents as we used the last time, we're going to use our primary category. The rest stays the same. Scale Y is going to change extensively. So scale Y becomes a linear scale, and it's complicated. The calculating the domain is complicated. The range will be, as it always is for bar charts, for vertical bar charts, plot a 2-element array, plot height and 0. The domain is more complex because our data is more complex. The nature of stacked data are those arrays of 2-element arrays. So our starting element is going to be 0, and then our ending element for the scale Y is going to be a D3 max. We're going to try and get the D3 max of our stacked data, but to get the D3 max for stacked data, we have to first get the max of the second element, the 1th element in each of our elements, and then get the max of those. And that's what this formula does. It looks complex. It is complex, but it works. That's how it works. If you bang away on it yourself in the console, you'll see how it works out. But you have, with any of these formulae that you're not used to, you have to go in there and look around them from the inside, or else you won't get them. Okay, the scale color is simpler than it was. This is going to be an ordinal scale where we're going to map our secondary category to one of the D3 standard sets of colors, scheme tableau 10. So we're going to get rid of the heat map. Don't use that. We're going to keep the formatter. Formatter is always handy. We can delete it later. There aren't going to be any labels on these bars as such. The axes should be fine. We won't need to transform the x-axis labels. So there you go. And now it's time to create the visualization, which is just a little bit gnarly. So we start our visualization with plot append G, and then select all G, data stack data, and here instead of enter we have join, and we're just going to make a little note of join. Joins are unusual, and you use them with kind of nested data like this. I've put in 2 links to the official documentation for joins, and you can read them at your leisure. And if you understand them, you might let me know, because I certainly don't. I'm copying the recipe here. I don't properly understand this. I do understand that it works, and right now that's good enough for me. Anyway, whinging over. After the first join, you fill it with D scale color D key. Then you select all rectangle. Data is called again. This time D maps to D, because again this is stacked data, so you go inside the stacks. That's what the D maps to D stands for there. We join again another rectangle, and here we start drawing the rectangles as we understand it, with X, Y, width and height. So the X is D scale X D data year, because we're using year as our primary category. Attribute Y is D scale Y D1, because we're using the 1th element of the stack data that we looked at. Our attribute height will be the difference between the 2 elements that we looked at. So that's D0. Sorry, it's scale Y D0 minus D1. and the width then is scale x bandwidth. We don't need an accessor for this because it's a constant scale whatever bandwidth, and a band scale is always a constant, so it's just like writing a number or a color there. It's always the same. You don't need an accessor when it's always the same. Okay, we're going to go have a look at this now, and we're going to hope really hard that it works. Launch the terminal, launch the server, launch the Fox at localhost 8000. Okay, so it almost works. We obviously have a bar chart. It just hasn't come out that pretty. And the fill, it's filling with many colors. So we go up to our scale color. Okay, I see what I've done here. And this is a mistake that I make often. I've wrapped an array in an array. Or an array in an array. That should be just scale tableau because it already is an array. So we'll launch that. And here we go. Thank God. Here is our scale data, which, we can look at the rectangles here. See how they're composed. They're the blocks, they're written in blocks, so that in your head, if you were drawing this, you draw it year by year by year. D3 draws it continent by continent by continent and stacks up along the years as such. I think it's worth noting as well that the stacked bars work better for this particular visualization than the heat map did for this particular data set. So, one size doesn't always fit all. The next thing we're going to do now is we're going to label the axes. So, in order to save ourselves a little time, we're going to go to GitHub, and there we're going to look up one of the earlier tutorials that had axes labels in them, because axes labels are reasonably straightforward. So here we are at lesson 7. These are the labels, and we're just going to copy them across. And we paste them in, and we make such adjustments as are necessary. We're going to call them, we're going to give them names, because that is often useful. And it doesn't cost anything, you know what I mean? It's better to have a name and not to need it, and yada yada. This is our X label and Y label. And the only thing we need to change really are the text. The text aspects of it. The X label is year, and the Y label is population. Millions in brackets. That all looks okay. So launch terminal, launch your server, launch the Fox, and take a peek. And there's no labels. Oh, there they are. Okay, so what we need to do here is change the text anchor. And to do that, we need to go to the style sheet. We identify the labels because we gave them a class of axis label. So in the style sheet, we're going to create an axis label class, as we did in back in lesson 7. As we didn't back in lesson 7, I see embarrassingly here on GitHub. That's right. Axis labels aren't hard to style. It won't prove that exhausting. Axis label, and we're going to set the text anchor to end. So as it is now, they're being drawn from the start, which means that they're disappearing off the end and the top of the of the canvas. So I'm going to reload the Fox, and here they are appearing properly now as they should. Now we'll just move this one a little. Okay, that looks a bit better. So these are just some small adjustments on the bottom margin, just to create, insofar as you can visually judge, the best balance between the axis labels, the axis ticks, the tick text, and all the rest of it. And we move on now to labels, or excuse me, not labels, legends, because it's not obvious from the colours what these bars represent. So we're going to have to tell people you're using a legend. Two ways of creating a legend. One is the standard one that you've seen, where there's a dot that represents the colour and then a label. So blue is Africa in this case, orange is Asia. The other way to do it is to write the labels in the colours themselves, which can work, mightn't work. In this case, we're going to do the dots and the labels because that's the most comprehensive. So create a legend object by appending G to the canvas and giving it an attribute, a class legend. Create the circles. Legend, select all circle data secondary category, because that's the one that contains the continent names. And then enter. To this we append a circle, and then we go through the characteristics of a circle, which is a class. It'll be legend circle, and then a CX, CY, a radius, and a fill. So CX is going to be the plot width plus the margin left, or I suppose reading it in order, you come in from the margin left plus the plot width will bring you to the very edge of the plot, and then we're going to add 10 just for spacing. And the X attribute will also be the same because we want these things to line up in order. The Y attribute is going to have to change. So for that, we iterate, instead of just iterating a D, we iterate DI, where I is for index. And to return the position there, we start off with an initial position of 15, so that we don't start at the very top. And on each iteration of I, we multiply I by 25. So it's 0, 15 plus 0, 15 plus 25, 15 plus 75, and so on. We'll set the radius to 5. The radius is going to be trial and error. I already know it's 5 because obviously I've been planning this in my layer. Okay, those should work now, so we might as well take a look. Launch terminal, launch server, launch the Fox. Okay, and there's our 6 circles. Take a look in the inspector, and there's our 6 circles. Fantastic, couldn't be happier. So now we do the circle labels, and we repeat essentially the same same process, where we have legend select all legend this time instead of select all circle. And to this we have data with secondary category as the data parameter, and we append text instead of appending a circle. The text attributes are fewer. There's a class which is legend label. The X attribute will be the same pattern as the CX for the circles. So it's plot width plus margin left plus 17 to allow for the diameter of the circle plus 2 pixels. That's where the 17 comes from. And the Y is the same formula again, except we've a different start. Where we're starting at 15 the last time, we're starting at 20 here. Again, that's to allow it to line up against the circle. Back and forth. It's easier to figure it out going back and forth on it than to write out a formula. The formula ends up being more complex than is helpful, really, and it doesn't take you long to figure it when you're going back and forth. And the text is D maps to D because we just have a simple array here. That's what works. And the text is a mess. Go back and look. Okay, I have I plus 25 instead of I multiplied by 25, so that's an easy fix. Okay, so our labels are correctly matching our text, but there is one small thing, and that is that the labels are in a different order that the colors appear. Now, you know, that's not an emergency, but it is better. You want to give the user the fewest hurdles to jump as possible. So we're going to put them in the same order. And the way we do that is by reversing the secondary category array, saving it as a new array, legend labels. So here we change the data parameter in each of the circles in the legend text to legend labels, and that will hopefully produce the labels in the correct order. And here we are in the correct order, which is, you know, it's just easier for someone scanning the graph to get what's going on. Now a tooltip, and then we'll be able to call it a day. So the easiest way to create a tooltip is, of course, to copy it across from GitHub. So we go back to the lesson 7 that we were looking at earlier, and we copy the tooltip code across. The only thing we have to change here will be the text that's displayed. The rest of it will be fine, you know, because it's just about creating the tooltip and writing in the event responses. So we'll just clear out tooltip text for now. That's all fine. Now we need to identify 3 variables. The first variable we're going to call primary tip. And the primary tip is going to match primary category, which will be the year. It's ddata year. We'll work out for this. Now, I can't emphasize how important the next thing is. You can't use an arrow function if you're going to use the this object binding in JavaScript. Alright, so make a note to yourself, get it tattooed on your hand if you have to, but don't use an arrow function for this, because one of those bugs it'll take hours to find it. Don't ask me how I know. You can post on Stack Overflow about it, and all that'll happen is you'll get told off. Don't tell me how I know that either. Or don't ask me how I know that either. Anyway, I figured it out in the end through all the blows. So secondary tip, the slightly odd looking code for secondary tip is D3 select. Select takes this parent node as a parameter. Then you call datum, which is a function, and then you call key. And then the last thing that the last item that you want to pass to the tooltip text is population. So for that, again, we go to ddata and we find the key. The secondary tip will be the key of ddata that will give us the population. So if you remember how the data, and you can scroll back in the video to take a look, how the data is arranged, it has a population associated with every continent. So That's how it finds it in this case. We'll be looking at it a little more closely later anyway. Okay, so we have our three parameters to add to tooltip text, and we start arranging them in the text now, which is an interpolated string. So the first thing we're going to have is the primary tip, which is the continent, and then we will put in a colon to show the year associated with this continent. And that'll be the secondary tip. We put in a break then, and then we write population, and our last variable lets us use our comma formatter at last to make the tooltip a little more readable. So that all looks fine. The next thing to do is to add the tooltip style, which again we can copy from GitHub. Just copy across the tooltip styling from before. Again, very little changes. The height should be less than it was for the Irish data set. But again, these are small tweaks. As long as the thing is working, we can consider this a success. You know, we're not gonna sweat the deets on this one. That's just an extraneous curly brace that I copied across. Easy fixed. Okay, launch the Fox, hope for the best. And our tooltip isn't showing up. The reason our tooltip isn't showing up is because that's not a function. Go back and look. Okay, I've written 2 brackets after key. I shouldn't have. It should be just key. Key's an attribute. It's not a function. Let's just delete those back. And hooray, it's working. It's not the prettiest tooltip in the world. You can jazz it up a little on your own dime. You know, I'd just be wasting your time here doing it because you've done it already, you know. What I will do though is we will look at the secondary tip and this select node. So the first thing we'll do is we log this itself to the console, because you know we want to know what it is. And in this case, this is the rectangle class bar, and it's just that particular rectangle. So it's the continent and the decade and the population for that particular rectangle. Okay, so the next thing to look at is parent node. So we're going to look at this dot parent node, and the parent node is the G division in which the 8 bars are held, and the bars are all grouped by continent, and the key here is South America. So that's the key, the datum.key that we were looking at. D3 select has a datum method. This parent node doesn't itself. Okay, so that's it. That's how it works. That's a stack bar chart in working order. Thanks for listening to it. I hope that you were able to. I hope that you know D3 a little better now, because some of these things are properly difficult, and it's not that you're stupid that you couldn't get them out working out. It's just that they are complicated, and that's why it's taken us so long in all these tutorials. Back next week with another one. In the meantime, live long and prosper.